For this problem, we have to figure out how many different ways the coloring page can look like. We know that Myra has a blue crayon and a red crayon. We also know that she starts coloring a coloring page that has two flowers. So let's start by coloring the two flowers the same color. So we can color both of these flowers red. We can also color both of these flowers blue. So now let's color one of the flowers red and one of the flowers blue. So let's start by coloring the flower on the left blue and the flower on the right red. Now let's switch the colors on these flowers and color the one on the left red and the one on the right blue. So now we can count the number of ways and we get 4 ways. So 4 ways is our answer. For this problem, we have to figure out how many ways Tanisha can build a tower using a red, purple, and pink block. Let's start by having the red block on top. We can swap the position of these two blocks to build another tower. This would be all of our towers that we can build with a red block on top. So now let's have the purple block on top. We can swap the position of these two blocks. And this is all our towers that we can build with the purple block on top. So finally, let's move on to the pink block. Again, we can swap the position of these two blocks. We can only make these 6 towers, so the answer to this problem is 6 ways. For this problem, we have to figure out how many possible ways Misha can button up the coat for her teddy bear. We know that her teddy bear's coat has 3 buttons and that she can button them in whatever order she wants. So let's assume she starts with the top button. We can switch the position of these 2 buttons for another way that she can button her teddy bear. Now let's assume that she starts with the middle button first, because these are the only 2 ways that she can start with the top button. We can switch the position of these 2 buttons for another way. And finally, we can start with the bottom button first. And again, we can switch these 2 buttons. This is all the ways that she can button her teddy bear, so the answer to this problem is 6 ways. For this problem, we have to figure out how many different ways Miss Hines can put 3 flowers into 2 vases, so that each vase has at least 1 flower. Let's use a chart to help us solve this problem. Let's have vase 1 be on the left, and vase 2 be on the right. Let's start by putting 1 flower into vase 1, and since there are 3 flowers, we can put a purple, red, and blue, respectively, into vase 1. If we put a purple into vase 1, that means the 2 flowers left over are a blue and a red. If we put a red in vase 1, that means the 2 flowers left over are a blue and a purple. If we put a blue into vase 1, that means the 2 flowers left over are a purple and a red. Now let's put a single flower into vase 2. If we put a purple in vase 2, that means the 2 flowers left over are a blue and a red. If we put a red into vase 2, that means the 2 flowers left over are a blue and a purple. If we put a blue into vase 2, that means the 2 flowers left over are a purple and a red. So the answer to this problem is 6 ways. For this problem, we have to figure out how many 2-digit numbers can be formed from these cards. Let's use a chart to help us solve this problem. Let's have the tens digit on the left, and the units digit on the right. Let's start with 1 in our tens digit. That means for our units digit, it can either be a 3, 4, or 7. If we have a 3 in our tens digit, that means our units digit can be a 1, 4, or 7. If we have a 4 in our tens digit, that means our units digit can be a 1, 3, or 7. And finally, if we have a 7 in our tens digit, our units digit can be a 1, 3, or 4. So this would be 12 numbers, so the answer to this problem is 12 numbers. For this problem, we have to figure out how many numbers we can make by placing 6 beads on either the tens or the units place. Let's use a chart to help us solve this problem. Let's start with all of our beads in the tens digit, and then we can work our way to 0. So that means we would start with 6 beads in the tens, 0 in the units, 5 in the tens, 1 in the units, 4 in the tens, 2 in the units, 3 in the tens, 3 in the units, 2 in the tens, 4 in the units, 1 in the tens, 5 in the units, and finally 0 in the tens and 6 in the units. So this is 7 numbers, so the answer to this problem is 7 numbers. For this problem, we have to figure out how many possibilities the amount would be less than $75. We know that Trisha has a $1 bill, $5 bill, $10 bill, $20 bill, and a $50 bill. We also know that she closes her eyes and selects one of the bills out of the jar. Let's start by finding the sum of the bills. So we can do 1 plus 5 plus 10 plus 20 plus 50. And we get a sum of 86. Now we can start taking one of the bills out of the jar. Let's start with the $1 bill. If we take the $1 bill out of the jar, the remaining amount would be 86 minus 1, which is 85. Now let's move on to the $5 bill. The remaining amount would be 86 minus 5, which is 81. Now let's move on to the $10 bill. The remaining amount would be 86 minus 10, which is 76. Now let's do the $20 bill. The remaining amount would be 86 minus 20, which is 66. And finally, we can do the $50 bill. The remaining amount would be 86 minus 50, which is 36. So out of these 5 possibilities, the only 2 possibilities less than $75 is 66 and 36. So the answer to this problem is 2 possibilities. For this problem, we have to figure out how many different sets of 4 dots can be joined to form a square. So let's start by drawing the smallest square possible, which would be one of this size. There are 5 of them, so I can write 5 under this. Now let's move on to a square that is slightly larger than this square, and it would be one of this size. There are 4 of these squares, so I can write 4 under here. Now let's move on to the largest square possible, which is a square of this size. There are 2 of them, so I would write 2 under this. Now we can add 5 plus 4 plus 2, and we get 11. So the answer to this problem is 11 sets. For this problem, we have to figure out the total number of different paths in the diagram. Let's look at the diagram on the right. We see that there is one B, so that means there is one way to choose the letter B. There are two R's, so there are two ways to choose the letter R. There are three A's, so there are three ways to choose the letter A. There are two V's, so there are two ways to choose the letter V. There is one O, so that means there is one way to choose the letter O. We can find the number of different paths by multiplying the number of ways there are to choose each letter. In this case, it would be 1 times 2 times 3 times 2 times 1, and that would give us a product of 12. So the answer to this problem is 12 paths. For this problem, we have to find out how many different bracelets there are. We can start by making a bracelet that contains only one color. So in this case, we can make a bracelet that contains 4 blue beads and 4 red beads. Next, we can make a bracelet that contains 3 of one color and 1 of the other. So we can make a bracelet that contains 3 blue and 1 red. We can also make a bracelet that contains 3 red and 1 blue. Finally, we can make a bracelet that contains 2 red and 2 blues. So we can make a bracelet that is red red, blue blue, and a red blue, red blue. There are 6 bracelets here, so the answer to this problem is 6 bracelets. For this problem, we have to figure out how many different bracelets there are if Veronica uses 6 beads in her design. We can start by finding the bracelets that only use one color. Next, we can list out bracelets that contain 5 of one color and 1 of the other color. Now we can list out bracelets that contain 4 of one color and 2 of the other. Finally, we can list out the bracelets that contain 3 of each color. We listed out 13 different bracelets, so the answer to this problem is 13 bracelets. For this problem, we have to figure out how many possible combinations of fruits that Katie could have bought. We know that Jackson bought 3 apples and 4 oranges. We also know that Katie bought apples, oranges, and pears. So let's find out how many fruits Jackson bought first. He bought 3 apples and 4 oranges, so we can do 3 plus 4 to find the total number of fruits he bought. And we get that he bought 7 fruits. So that means Katie also bought 7 fruits. We can make a chart to find out how many combinations she could have bought. So if we make a chart, we see that there are 15 combinations. So that means the answer to this problem would be 15 combinations. For this problem, we have to find how many combinations result from choosing a cone or a cup, one kind of ice cream, and one topping. When ordering an ice cream, the first step is choosing a cone or a cup. And there are 2 options. The next step is choosing the kind of ice cream. In this case, we can choose between chocolate, vanilla, or strawberry. So that means we have 3 options. Next, we have to choose our topping. In this case, we can choose between sprinkles, peanuts, or hot fudge. So that means there are 3 options. To find the total number of different combinations, we would simply multiply the number of options at each step. So in this case, we will multiply 2 times 3 times 3, and we get 18. So the answer to this problem is 18 combinations. For this problem, we have to figure out how many distinct ways the letters in the word peace can be arranged. Since peace is a 5-letter word, that means the resulting word is also 5 letters. The first letter has 5 options because none of the letters have been used so far. The second letter has 4 options because only one of the letters have been used. The third letter has 3 options because 2 of the letters have been used. The fourth letter has 2 options because 3 of the letters have been used. And finally, the last letter has only 1 option because 4 of the letters have been used. We can find the total number of distinct ways the letter peace can be arranged by multiplying these options. So that would be 5 times 4 times 3 times 2 times 1, and that would give us 120. But since E occurs 2 times in the word peace, we have to divide this by 2. So we will do 120 divided by 2, and we get 60. So the answer to this problem would be 60 ways. For this problem, we have to figure out how many possible combinations of 2 cards could be inside the envelope with the number 8. We also have to figure out what those combinations are. We know that a set has 10 cards, and they are showing the digits 0 through 9, and they are divided between 5 envelopes so that there are 2 cards in each envelope, and the sum of the cards inside is written on each envelope. We can solve this problem by making a chart. If we make a chart, we get something similar to this. We can see from this chart that there are 3 possibilities, and the possibilities are 7 and 1, 5 and 3, and 0 and 8. So the answer to this problem would be 3 possibilities that are 7 and 1, 5 and 3, and 0 and 8. For part A of this problem, we have to figure out how many possible combinations of numbers can result from a roll of 2 regular 6-sided dice. The first dice can have 6 possible combinations, while the second dice can also have 6 possible combinations. The total number of combinations is the product of the combinations of the 2 dice. So in this case, we will do 6 times 6, and we get 36. So 36 combinations is the answer to this problem. For part B of this problem, we have to find out how many combinations there are that have a sum of 10 or greater. Let's start by finding the combinations that have a sum of exactly 10. So in this case, that would be 4 and 6, 6 and 4, and 5 plus 5. Now let's find the combinations that have a sum of exactly 11. That would be 6 plus 5, and 5 plus 6. Now let's find the combinations that have a sum of exactly 12, and that would be 6 plus 6. There are 6 combinations here, so the answer to part B of this problem would be 6 combinations. For this problem, we have to find out how many solutions there are. I would recommend solving this problem through trial and error. I would start by finding what numbers each letter cannot be. For example, T cannot be 4 or less, because T plus T results in a 2-digit number, so that means T must be 5 or more. Also, O cannot be 0, because if O was 0, then 0 plus 0 would be 0, so this R would have been an O. We can use this logic to solve this problem, and through trial and error, we eventually get these 7 solutions. So the answer to this problem would be 7 solutions. For this problem, we have to figure out how many times a 5 appears over a 24-hour period. Let's start by figuring out how many times a 5 appears in the minutes part. A 5 appears at 5 minutes, 15, 25, 35, 45, and 50 through 59. It appears a total of 16 times since 55 contains 2 5s. There are 24 hours in a 24-hour period, so to find the number of times a 5 appears in the minutes part, we can do 16 times 24. And we get 384. Now let's find how many times a 5 appears in the hours part. A 5 appears at 5 and 15. The 5 appears for the entire hour, which is 60 minutes, so to figure out how many times a 5 appears for the hours part, we can simply do 2 times 60, which gives us 120. So the total amount of times a 5 appears in the minutes part and hours part is 384 plus 120, which gives us 504. So the answer to this problem is 504 times.